All right, let's continue here. So as I was telling you, this is a database on the heat anomalies for the entire planet according to one of their system models for the year 1950. And just as an example here, in this row, we had, this is the cell ID. This is an identifier for that cell, for a grid. This is the heat anomaly number 12. This is the percentage humidity on that place. And over here you had the start date, the end date, and it lasted for about 8 days. All right, so what I want to do with these couple files today is to see if first there are differences in the number of heat anomalies between 1950 and the year 2100. Those are the two files there. You remember here on the files that I just submitted to you. And where are we now? Courses, stations, methods, class 3. So here, those are the two files that I'm going to submit to you. So we had the heat anomalies for 1950 and 2099 according to one emission scenario, and we want to find out if the number of heat anomalies was different on those two places. All right, so here we're going to go to our TinR, right, which is the program where we're going to develop the code, and we're going to start from here. So we're going to start by creating a variable that we're going to call heat 1950. By the way, R doesn't allow you, doesn't accept naming variables with numbers. So every time that you name a variable, it has to be with, starts with a letter. So for instance, I cannot create a variable that is called 1950 is equal to 5, let's say, right? So in this case, we will say this is a variable that is called 1950 and I want the variable to be 5. R doesn't accept that, right? So you actually need to, you want to generate a variable, you have to enter a letter at the end, at the start of that. And now you do have a variable that is called x1950 there, right? All right. So let's go back to our TinR. So we're going to start a variable. So the first thing that you need to do, and that's one recommendation that I want to give you, is to always that you write a code, explain what the code is, right? Right now you are probably very familiar with what you are going to be doing, but in 2-3 years you might want to go back to this and you need to understand what this is about. So anytime that you are doing something new, you should probably describe it there. So we're going to say this is a code to compare heat anomalies between 1950 and 2099. You can add, this was done by Camilo in October, November 4, right? So just try to keep a catalog there of what you are doing. Every time later on that you do a change on the database, or to this code, it's always good to describe what you did here. Again, you just need to be sure that years from now you can come back to this and pick it up quickly. All right, so we're going to introduce a variable. We're going to call it x1950, and that's going to be the file that is in 1950. So that's the folder here, right? So you remember from our last tutorial, the way in which you read a file is using the fret function. And again, I will show you something in a second. You just need to enter the name of the path where it is. Right click on the name of the file, click rename, then copy all of that, copy that, Control C, and then paste it here on the name, and then close quotations and close brackets. Right, so just remember that you need to change these things there. So if I run this in R right now, it's gonna give me an error, right? It couldn't find function fret. So So I'm gonna give you a second to think what could be the reason for that error there. So the reason for that error, if you remember from the last tutorial, fret is a function that was created as part of a library that is already created. So the first thing that you need to do is to load that library, right? So in our code, we're gonna type library. That's the function to load any library, and the library that we want to load, if you remember, is called data.table, right? So if we copy that, and now we load that file, sorry, that library in R, by just clicking enter, takes a little bit. You say it was loaded. So now we can run our line of code now, and the file has been loaded already, right? That's because, again, the function fret now is available to R. So that's 1950. We are gonna enter now. We are gonna load now the database for the year 2099. 2099. Oh. And we need to change the name of the file here, which is 1929, and we can just load that file, right? All right, so it says that that file doesn't exist, so let's just go and find out what happens. So what happens is that the name of the file is different, so we just need to right click, rename, copy the name of the file, go back to TinR, and again replace the name of the file on your string there. And now we can copy this, paste it in R, and just wait a second for it to load. So now we had the two files there, right? So we had the database for 1950 right there, and the database for the year 1999. All right, so just gonna introduce very quickly here something that I don't know if I introduced before. We're gonna do a plot. Let's, for instance, look at what is the correlation between temperature and humidity on this on 1950, right? So we can just copy the name of the database. The way to do a plot, just to visualize the data, is plot, open brackets, you type the name of the database, you use the $sign, you copy the name of the variable. So we're gonna plot relative humidity, which is that variable. You use this sign, you copy the name of the variable again with a $sign, and we are gonna plot that against temperature, which is this variable here, TAS, right? So right now what we are doing here is just generating a plot from the database called X1950 relative humidity, the variable relative humidity, against the database 1950 and the variable temperature. You click enter. There is the correlation for all of the pixels, all of the heat anomalies in the year 1950, right? All right. So that's how you do a plot in R. Obviously, if you want to get more information on how to modify the axis and another stuff, actually, let's just do this plot here between, this is how far from the peak of the summer it was, right? So this is where it happens, right at the peak of the summer. This is the number of days. This variable here is the number of days from the peak of the summer when the heat anomaly happened. So this heat anomaly here, they happened 139 days before or after the peak of the summer. I want to compare that against the duration just to see if long anomaly. Let's see just what happens there. I haven't really done that. Oopsie. So I need to copy duration there. Click enter. All right. So this is how far again from the peak of the summer a heat anomaly is, and this is how long the heat anomaly was, right? So obviously you get like a triangular shape there. Well, I don't know how to interpret this yet, but anyway, that's how you do your plots. You can, for instance, note the different names of the axes here. So you want to find out more information that you want to change, how to edit this figure. One thing that you can do is type a question mark. So every time that you want to get new help about a function, you type question mark, and then the function, which is called plot, you click enter, and that will bring to you all of the information about that, how to use that function plot, which is part of graphics, which is part of the origin thing there in the insides of this. So for instance, here you had main is an overall title over the plot. So if we copy this main, we go back to our plot, we do it again, and here we put comma main, and we're gonna put a name to it, right? Keep in mind, because it's a test, so you need to put quotations. So we're gonna call it heat anomalies 1950 anomalies, close quotations, and click enter. But you can see that main, the function, from this function plot, this capacity of main is what allows you to put a title to your plots. So you go back again to the help, you get sub, which is again, you just put in a subtitle there. Xlab is where you want to put a name to the x-axis. So let's see what xlab does. So again, you go back to your R, we're going to type xlab is equal, and we are going to call it to duration, right, which is the name of the x-axis. So you can see how that function there changed duration there. You can do the same thing for the y-axis, and we're going to call it now, as you can imagine, it's probably going to be called ylab equal, we are going to call it peak of summer time to peak of summer, close quotations. And as you can see, that will put the name to that axis there. So again, if you go back to your help, to the help from that function, you get all kind of other additional information there that allows you to play around with your how to make that plot better. Now, one thing that is very nice about R is the fact that all of the help menus, all of the help functionality of pretty much every function is one of their standards. At the bottom of it, it always provides you with an example of how to use that function, right? So here it gives you just an example. So you copy these 3 lines of code, you can go to your to your R, paste in there. It will give you an example there of how to plot your how to use that function plot. Again, let's just look at another example, like for instance mean, which is the average. Again, it tells you what you need to enter to calculate the mean value, and here is just an example there, right? So this is an example to calculate the mean. So you copy these two. The mean that gives you this value is 8.75. So what is that example? So what they had done there on the help for menu is to generate a variable that is called x, and that variable x is a database, basically a compilation of numbers between 0 and 10 and the number 50. Let's see what this does, right? So it creates an array of numbers between 0 to 10, 0, so you can see here 0, 1, 2, all the way to 10, and then it adds 50, right? And okay, so that's what this line of code does here, and here then xmem calculates the mean of this variable that you just entered there. All right, anyway, so that's just a trick there. Anytime that you encounter a problem with a function that you don't know how to do it, all what you need to do is again type the question mark and the name of the variable, and Excel R will show you all of the information that is available about that function there. All right, let's go back to our tutorial today. Really what we want to do is to find out if there are differences in the number of heat anomalies between 1950 and the year 1999. So we have those two databases there. And what do we want to do? All right, so we are gonna select just, I guess we can select the cell ID, right, which is the place in the planet where that is, and the number of extreme heat anomalies, right? So what we are gonna do is we are just gonna select some columns, so we don't really use all of these other variables, but we are just interested on counting how many heat anomalies were on every cell on the planet between those two places. So let's go back to R. So here what we are interested in is we just want to take two columns there. The column of the cell ID, the grid ID, and the number of events, heat anomalies on that place. So we're going to type here how to select two columns from data table in R. Just see what kind of tutorials do you get there. Right? Again, keep in mind, from all of these database that has all of these variables, I just want to select these two columns here, right? So here, if I go to Google, I type what I want. There, let's just check out quickly this first tutorial, which I already opened up. So it just describes, again, I want to select two columns. How do I do that? And here is an example, right? So basically what you do, you need to load, this is an example here, you load the library, and then you create the table that has three variables, columns A, B, and C, and then here you select just columns 2 and 3. And with false is obviously probably some kind of information that it needs to, that Excel, that function will require. All right, so let's just go here. We had, obviously this is the name of the database here, so we select 1950. We want to select columns. If you go back to your thing there, so we want to select columns 1, we want to select columns 2 and 3. So that's fine with false. So let's see what that does. So there you can see it, right? So this function that we just found on the internet allows you to select from a database. These curly brackets then tells you, okay, from inside this database here, what do you need? So what I want, this comma separates the rows. So if I want to just, for instance, the first row, those two columns, I can type here 2, and that will give you the second row of columns 2 to 3. Right, there you can see it there, right? So because you didn't enter that number, it was empty, it's gonna select all of the rows. Now the next thing after that is to select the columns. So we are selecting columns 2 and 3, and with this function with equals false, it pretty much, I don't know what that does, but I presume that's something that is required for you to actually be able to use this function. All right. So if we go back to our thing R, we're going to enter here heat, we're going to generate a new variable that's called heat 1950, heat waves 1950, and that's going to be equals to the database of 1950 of all of the heat waves of 1950, and we just want the columns 2 and 3. We do the same thing for now 1999. And here we have to select the database 1999 and select again columns 2 and 3. So let's just copy these two lines of code, paste them here. Pretty much what happens next is that we have two databases, one for 1950 and one for 1999. Now, one thing that we want to do now is to count. We're interested now in counting how many heat anomalies did happen on every cell, right? So right now, you remember from our from the Excel sheet, you had the cell ID. So these are all of the heat anomalies that happen on that cell number 1. So in this cell, by the way, the geographical coordinates of that cell is this number here. In that cell, there were 16 heat anomalies that happened in 1950, right? So that's what we want to do. We want to generate something that is called a pivot table, in which we just select the one the one number here, and count how many heat anomalies did happen on this cell 1. So we go again, Google is our friend here. Let's find out how we do this. So what we want to do is how to do a pivot table. Data.table in R. Again, the question that I ask is how to do a pivot table in data table in R. So here is a couple examples. Let's see what this one does. So again, it just tells you the important value of the data tables there. So how to do it in R, we scroll down, and okay, this one is probably not being very helpful here. Okay, I don't think this is group by. Okay, what is this one about? All right, I don't think this is very helpful. See this example here. So again, this creates a data table, enter some numbers there. Okay, this one thing here, so you can see creates a database. It has the summatory of these 3 columns, so that could actually work there. Okay, let's see what this one does. So again, we are generating a variable that is called ANS. Use the function that is called decas. It's taking this database. So our database is this one here, 1950. You'll see. So you just replace that by that. And what we want is thing is probably gonna be. Let's copy the name of the 2 columns. So we want D by category, right? So we want the cell ID against, so that will be the rows, 1 colon, and this will be the second colon, and the function that is going to integrate cell ID by number is going to be called length, which is count. Let's see what this does. So we type ANS. Okay, this is probably not the one that I wanted to do. So I'm just gonna